Hello there. I'm going to attempt to replicate some of those modeling techniques. Let's begin. If I do any mistake, you should know that I do it on purpose to test your knowledge. So first of all, one of the main tricks they do in tutorials is to plan the topology of the object so that they comply. I'll show you exactly what I mean. Now, the main question I was asked by my fellow C4D user, Mustard Seed, was that Booleans create bad topology. That is a case if you don't prepare your topology to accommodate the specific Boolean. I'll give you a very small example before I begin. A typical problem we find with Booleans, let me make this sphere slightly smaller, and I'm going to cut a cavity from this cube using this sphere and using a Boolean. So I'm going to subtract object B from object A. When I teach sometimes Cinema 4D, I have to explain, in order to get the rule properly, A subtract B, always add an A and a B on your objects. Now you can see that this has created a sort of a mess of a topology. And a few things we need to consider in this situation. The first thing would be we need to hide the new edges. Okay, when we hide new edges, basically it creates n-gons rather than triangles. Now sometimes, under certain circumstances, hiding new edges will create a few problems. But in this case, it will be nice and clean. Now the secondary problem is that you can see the sphere is looking upwards. So basically its rotational symmetry is across the y-axis. If I take this sphere where we've created this weird, very weird bad topology, look at all these little triangles. These are issues we will have to face as we continue using the model later on. A simple thing we can do is get the sphere and rotate it 90 degrees this way. Now look at this nice, beautiful, clean topology. Even though we do have that little slither here, that slither is a quad, so that won't be a problem. So orienting and preparing your objects for the appropriate function you're going to apply, Boolean in this case, will give you a much cleaner topology. This is a perfect model. You will not have topology problems if you respect the let's say the structure of each object. Okay, so this is okay, whereas this is not okay. As simple as that. So anyway, we are going to use this rule. The second rule is that the number of polygons need to comply with what we are trying to do. So let me give you the case in this situation. So if we are going to create some kind of extra modeling on this model after we make it editable, and we will need to connect polygons or whatever, create a hole or something like that. The sphere has 24 segments and the cube has 4 segments. We need to make sure that the number of segments of the one object can be divided by the number of the other object. They don't always have to be the same, but that is a general rule of thumb. If I get the cube and I add segments, on this axis, now we've got 3 by 4. Then let's see what would happen, if we would like to start connecting parts of this. We will have overlaps here, we will have weird n-gons. Maybe we need to take the cube and subdivide it even further so that the number of polygons that are going to be created can be equally matched. This is something we are going to do exactly in the following video, and it's something that the creator of the Modo tutorial actually did it. He had an 8-sided cylinder cutting out from 16 polygons, so that each edge of the polygon was could account to an edge on the bent object. Anyway, if that wasn't understood, you will realize exactly what I'm talking about. So let's start exactly as they started, and as far as I remember, the actual cylinder the gentleman used was 24 segments, and how I found that out, I paused the video and counted them. So let's get rid of the caps, and the next thing is I'm going to add height segments, just an arbitrary number for now, and I'm going to add a bend deformer. Now they've got that nice button they press and they bend it. I prefer to have deformers because being a parametric deformation, I can always tweak things later on to my liking. Anyway, so let's continue. I will create my bend deformer, and one thing I always tell my students about the bend deformer is that it's good for a bend deformer to comply to the shape of the object we are trying to modify, to deform. So the cylinder has a height of 200, so let's make the bend deformer slightly bigger, like 205, just so that there's it overlaps slightly. Then we see the cylinder has a radius of 50. That means a diameter of 100. Let's go to the bend object and put 105 here and 105 here. Okay, now we have a nice compliant deformer around our object, and we can drop it underneath, keep y-axis length, and bend it. There we go. So we have a nice bent little pipe here. Okay, providing that this is what we want. Now, another good measure, another nice thing you can do is make sure that your polygons are as square as possible. That is not always the case, but having nice, tidy, clean geometry always helps in the future. So we select the cylinder and we increase the number until we think that where we're going to cut that pipe, remember that shape, it will be nice and square, the polygons. There we go, so they look kind of square there. We don't even need to know exactly what number that is, as long as they are kind of square. So we're going to identify the area. We're going to put that other pipe around here. So I've got my base model ready. Now, in order to do all those fancy things, this needs to be made into a polygon object. So with my cylinder selected, I right click and I say current state to object, and there it is. Now what I, as a good practice, what I do, I create a null and I call it temp storage. Okay, and what I do here, I basically turn the traffic lights off, put everything in here, just in case I need to change something. Now, that's not a big problem because the object manager in Cinema 4D is very useful for these things. You can very quickly look into your hierarchy. Okay, nothing is hidden, nothing is complicated. So I've hidden everything here, and now I've got a cylinder, which is basically a polygon object. And as the gentleman said, I can move this around. I can move my axes around in an arbitrary angle. So this is totally out of place. It's the axis is somewhere else. I don't even care. We can always correct this. So number one, we don't have a construction, well, we do have a construction plane, but my preferred way of working is not using a construction plane, and that is that. That is my opinion, and I think Cinema 4D works better. So what we need to do basically is create an axis which is relevant to the selected polygon. So he selects 16 polygons. Okay, there we go. 16 polygons. Okay. Now, let's see what happens with these 16 polygons. First of all, we've got the ability to align the axes of the object based on a polygon selection, and that is the axis center tool. Axis center. Sometimes I may lose the menus because I'm still using release 12 and release 13 for projects. So anyway, axis center, and basically the axis center allows us to place the axes of the object based on a selection. All you need to do is say alignment to the normals of the selected polygons, execute, and then what you will get is the axes of the object to become the axes of that polygon selection. From now on, anything we do in regards to this object's axes will be perpendicular to the average normals of these polygons. And I'll show you how that helps further down the line. I will create my cylinder now. That cylinder we are going to place right over this object. I will make it 8 rotations, and I'll keep the caps for now. I can always get rid of them later on. And if I make it a child of the cylinder, I'll call this bent, and I'll call this pipe. Pipe extension. Excellent. Now, because this object now has an axis, a local axis like that, if I take the pipe extension as a child of the object, I can go to my coordinates manager and I can zero out these. There we go. How cool is that? It's exactly where we want it now. And all I need to do is make my pipe smaller, so it fits within these 16 polygons here. Now, sometimes, sorry, people say, yeah, I can't identify them, I can't see them. We can always use nice little workarounds to make our life easier, providing that we're comfortable with Cinema 4D's interface. So remember, the selection always, Cinema 4D always remembers the selection. I can go there and add a selection over here. Okay, now why would I do that? Well, for the easy purpose of, just for the sake of visibility, we can add a material tag with this selection and we can always see what these polygons are. So this is something that wasn't in the original Modo video, but you know, it's good that we can do things as fast as this, so we can have visual cues. At any point we want, we just delete this and everything is clean again. All right. So as you can see, we've got 8 rotational segments for this cylinder, and basically because we've got 16 over here, you will see that we get a very good point-to-point compliance. So these two edges will meet here, this edge will meet here, these two edges will meet here, and so forth. Now, even in Modo, I'm pretty sure the gentleman would have a rough time connecting this object to this if it wasn't for the right number of polygons. So don't believe the hype. Sometimes the project that you see in videos has been prepared specifically to work seamlessly with the techniques that someone wants to show. Sorry again. Oh, let's continue. I've placed my cylinder. Let's see how much it's further down than I want it to be. I'm going to move it up. There you go. And now let's do the quote-unquote projection, and that will be a simple Boolean. So here's my Boolean, here's my bent object, here's my pipe extension, and basically there you go, I've got my points. Now I can choose one of my Boolean methods in order to retain the top part, and I would say union B. That's good, and I can hide new edges, and this is pretty much what I get here. Now someone would say, yeah, but look at this, you know, you got extra points. Okay, the gentleman in the Modo video did do some cleaning up, moving points around. What he couldn't do is, after you see your topology, he can't go and change the size of the cylinder, which is something we can do dynamically. Anyway, providing we're happy with this, it's going to take just a few extra steps to remedy all the possible problems. What I normally do is take my Boolean, make a copy in here, just in case I want to go back, and it doesn't really, you know, affect memory. Cinema 4D files are quite small anyway. So Boolean, make editable. So now I have basically 2 objects here. Oops, just want to take them out of the hierarchy, get rid of the bool, and let's get rid of this. We don't need this, we don't need that selection, or maybe we do. So yeah, double click. We don't really need that selection anyway, and I can select these 2 objects and I can join them. But before I join them, what I'm going to do, I'm going to clean them up. So I will go to this object, select points mode, and you know something, I'm not even going to bother with this yet, even though I could very easily clean up these points and then go and connect them to my cylinder. So what I'll do, I think the best thing in this case, let me get rid of the bent object, sorry. There you go. What I really need to do though is just get rid of these extra little points. That's it. That's the only cleanup we need to do at this point. Probably another modeling technique can take care of this automatically, but I'm just showing you the raw basics of modeling this way using Booleans. Okay, small cleanup. I mean, the 30 seconds or less it's going to take me to clean up, I've already saved by having parametric objects and controlling how the object looks a bit better. So there we go. So number 2. Now again, choosing your preferred method of modeling. is always a must. Okay, so in this case, what's more important for us is that we keep the shape of the cylinder proper. And if we're going to play around with any shapes, it's going to be these polygons here. So I won't touch the pipe segments. I will only touch the bent segments. Okay, so what I will do in this case, I will select these 3 points and weld them right in the middle. Okay, now this is something I can do when the two objects are connected anyway. Okay, so let's continue here. Let me think. All right, no, you know what I'm going to do? I'm going to make it even simpler. I'm going to get rid of this. Totally. So the only basic correction we did was on the cylinder. Okay, and now I'm going to use the equivalent tool, the create polygon the gentleman did, and all I need is the edge. First of all, let's select everything and right click and optimize, get rid of any unused points. Then I'm going to select the edge and bridge. These two connect object and delete. And now I'm going to drag this over here. Again, I'm using the bridge tool in edge mode. Drag this here. Drag this here. Drag this here. This here. This here. That there. I think it's faster than creating 4 points and all that. Lovely. And then I right click again and I say close polygon hole. There it is. And just hover over here and click, of course. Hover and click. Hover and click. Ta-da! Beautiful. Okay. We can drop this under a hypernobes and see what happens. So let's turn it off and use my knife tool in loop mode and just go and slice this up right down there. There you go. Brilliant little pipe connection. There you go. I've identified some kind of issue here. Apparently some points were not touching each other. I don't know why this happened. Anyway, I select them both and I go weld, and I think this is going to be remedied. Very, very simple to fix. And I've got these two pipes connected. Let's continue. I will select the whole top part of the cylinder and I will do a melt. Z is a melt. Then inner extrude, pressing the I button, and then I can do whatever I like to this. Extrude and extrude again. Nice, brilliant, nice little fillet. It was too thin, I think. I'm going to try it one more time, a bit thicker, and extrude. And if you want your hypernobes to work nicely along curves, you need to have at least 3 cuts per angle. Anyway, that's for another lesson. So one here and one in there. Whoops, wrong angle. There we go. Look at that, perfect. And I can move the bottom part as far down as I want. Nice little pipe connected, clean geometry, no problem. Now the only thing we can't do automatically, what the gentleman did, is if we select this loop selection here, when the gentleman did a bevel, it was much cleaner. It didn't create these double edges. But you know something? Just keep your n-gons on, and then all you need to do is use points and just clean up these areas using the weld. These two, right click, weld, click there, come back here, space bar to go to previous tool, space bar to go to next tool, go around, space bar, click, move around, space bar, click, move around. Okay, he did it faster, good for him. Okay, we will get this in cinema very, very soon. So again, I'm having some issues here with my topology, which I've remedied. Probably, yeah, some point around here hasn't been stuck properly. We can see the topology nice and clean. But anyway, nothing more than what they can do in Modo. And you want to see it nice and shiny? Well, let's go and create I'll create a material, and I'll make this black, and go to my text folder and load this, which is just an environment, and put it there and get rid of this. And ooh, how nice and sweet. Okay, Nice. I'll dim it down a bit. There we go. Nice little material. Clean and brilliant. So, you know, with all the explanations and so forth, it doesn't take that long to do, does it? Yeah, but anyway, I hope this kind of helps. Never, ever, ever forget that you have to prepare. You cannot just go there and create any arbitrary number of rotations and expect objects to fit properly together. That cannot happen. Making sure your topology is proper and compliant from the beginning is a huge time saver, and sometimes it's the only way